Good morning, class. Today we are going to study structure of atoms, the chapter 4 of chemistry. But before starting the chapter, let me revise the third chapter, that was atoms and molecules. Do you remember the chapter atoms and molecules? How many of you tell me what is atom? Can anyone tell me what is atom? Fine. Yeah, atom is the indivisible part of any matter. And then we have already got molecules also. Molecules, we can say that one or two atoms when combined together can form molecules. Not only that, we have studied one main theory that is called Dalton's atomic theory in that chapter, which will play a very important role in this chapter as well, because the theory which Dalton has proposed, we have to study that, and then from that onwards we will come to the structure of atom. So let's get to the Dalton's theory first. And before going to Dalton's theory first, let me tell you what are we going to study in this chapter. Structure of atom, subatomic particles and atomic models. So as I have already told you what are the topics we will cover in this chapter, as you can say, discovery of electron, proton and neutron and their characteristics, Thomson's atomic model and its drawbacks, Rutherford's nuclear model and its drawback, atomic number and mass number, isotopes and isobars, and then we will study atomic models, Thomson model, Rutherford's nuclear model, atomic mass and mass number, isotopes, isobars and drawbacks. But today in this class, majorly we will focus on discovery of electron, proton and neutron and their characteristics, as well as we will also try to cover Thomson's model as well. Okay? So as I was already telling you about Dalton's atomic theory, from that only we can study our basic structure of atom. So what was Dalton's atomic theory? Dalton has given us few points. The first point was any matter which is the indivisible part, like if you divide any matter into pieces, then you will come into a point where you will not be able to divide that matter, and that undivisible part was called atoms. So we can say that the first atomic theory, it was proposed in 1808. This theory postulated that all matter is composed of very tiny particles called atom. As I have already told you, it is composed of very tiny, or you can say undivisible particle. And he also proposed that we cannot divide atoms. But this theory, we will in this chapter we will say that no, it was not correct. We can divide atoms, and we will study about the subatomic parts of the atom. Several theories, and then later on he has given after his theory, several theories came about structure of atoms, like what an atom is made up of. So basically we will study that what are the main components, or we can say what are the constituents of atom. So we have three things: electron, neutron and proton. As the discoveries went on, like we know that science, we have everyday new things come up. The new technology comes, like you have seen earlier we don't use a cell phone, now we have a cell phone. Then you can say that earlier there was nothing, now many things have come. Now though everything has been taken up by AI, artificial intelligence. So later on also many theories can also be proposed that maybe electrons are also made up of something, or maybe protons are also made up of something. Some theories may also come up in the future, because many scientists, many chemists are already working on it. Like they are trying to divide electrons, protons and neutrons as well. So discovery of electron. Electron was discovered by J.J. Thomson after the model was given, like Dalton's atomic theory was given. He has given the discovery of electron. Like what were the main things in the electron. So I'll show you the video also, and then I'll just discuss the thing. So it was discovered by J.J. Thomson by using a discharge tube experiment. In that discharge tube experiment, he has taken a glass tube, and at the both end of the tube he had added a cathode and anode. So cathode is negatively charged particle and anode is positively charged particle, and then he has passed some rays through it, cathode rays. The rays which are passing from cathode towards anode, we call it cathode rays. And then he has used some metals in it, and he found that some different things were happening. Like something was there inside an atom which was not letting it go. So that's why the you can say electrons discovery came into existence. So we can say a discharge tube is made up of glass and is filled up with gas, It consists of two metal electrons, cathode and the negative electrode, and then the positive electrode. The negative part, like we have seen in a battery, we have a negative side and a positive side. Two poles are there in a battery. So what the positive pole is called anode and the negatively poled are called cathode. So for electrical discharge, very low pressure and very high voltage must be maintained. So if you want to show electric, so you have to lower the pressure and higher the electric voltage you have to provide. Then pressure of gases is maintained with evacuation of the use of vacuum pump, and then we have to use a vacuum pump as well to see the pressure. So this is Rutherford's experiment. So let's see
Dalton's atomic
theory and then Thomson's Rutherford's
Dalton's atomic theory was proposed in the early 1800s by John Dalton, an English scientist. Dalton proposed that every element, meaning all matter on Earth, is composed of tiny, indivisible particles called atoms. These atoms cannot be created, destroyed, broken into smaller parts, or in any way transformed into atoms of another element. All of the atoms of the same element will always be identical in size, shape, and mass. Different elements will have different types of atoms. The atoms of different elements can be physically mixed together, or they can chemically combine.
As I have already told you, the Dalton's atomic theory, so we cannot divide anything. More on that, he has given that any matter, or you can say any compound or any molecule are made up of atoms, but in a fixed ratio. Like you cannot mix in your own way. So you want to make water, we know what is the formula of water, H2O. We have hydrogen and oxygen, atoms of hydrogen and atoms of oxygen. It is not your choice that you will mix hydrogen, like you have added 10 grams of hydrogen, 20 grams of oxygen, and then you found water. No, you will not get. So the ratio should be maintained. So if you are using 1 gram of hydrogen, then you have to use 8 grams of oxygen. So the ratio is maintained, like 1:8 is the ratio to make, you can say, water. So like that, every compound in our existing, they have a fixed ratio. Without that fixed ratio, nothing will happen. Like you cannot mix anything as your own choice. Secondly, he has given that whenever a chemical reaction is happening, so you are like, suppose the basic chemical reaction which you have studied in class 7 and 8, acid plus base gives salt and water. The basic, we can say that. When you mix an acid with a base, you get a salt and a water. So it doesn't mean that acid and base are mixed up together. It's like liquid you are mixing up and then you get a fresh juice. Not like that. It should be that atoms has to take part. Without atom taking part in that reaction, nothing will come. So every reaction, whenever there is a chemical reaction happening, atoms are the main thing which are taking part in that reaction. So this was the main 3 or 4 postulates which was given by Dalton's atomic theory.
Combine in simple whole number ratios to form compounds. When atoms are separated, joined, or rearranged, a chemical reaction will occur. Dalton's atomic theory was partly correct and partly incorrect. Dalton said that atoms were indivisible particles, but the modern theory of atom proved this to be incorrect, since atom,
as I have already told you, whatever the Dalton's theory was proposed, it was correct in the sense that there are indivisible particles which is called atom. But he also proposed that atoms cannot be further divided. The main thing he gave, that atoms cannot be further divided, which was proved to be wrong later on. We like many scientists, or like as soon as the discovery of electron came into existence by J.J. Thomson. So Dalton's atomic theory was failed. You can say that it was a failure for us. That okay, fine, we can say that chemical reaction atoms take place, but atom have also subatomic parts, which was later on found, and then Dalton's atomic theory was already failed.
Can be further subdivided into smaller units of electrons, protons, and neutrons. Dalton also suggested that atoms of the same element will be identical in size, shape, and mass. It was later discovered that atoms of the same element can actually differ in mass. For example, the element hydrogen can be found in three variant forms: protium, deuterium, and tritium, each of which has different masses. Elements having different mass numbers but the same atomic numbers are referred to as isotopes. Summary.
So, not only this, you can say atoms have same number of electron, proton, neutron. Some atoms have different numbers of neutron, proton, and electron. Based on that, we found mass number. We can say that mass number is the sum of proton and neutron. So, number of neutron and number of proton will be different for every atom, and the atomic number is number of proton. Right. So if an atom, or you can say if an element have three different mass number, but the atomic number is same. Like you have just now we got hydrogen. Hydrogen have three we can say different mass numbers, 1, 2, and 3. We call it protium, deuterium, and tritium. Right. So these three things are called isotopes. So basically we can say that isotopes are the elements, or you can say are the elements which have same atomic number but different mass number. So in this way you can find for oxygen as well, you can find for chlorine as well, like different elements have different isotopes. So like that we can find. Now we can go to Thomson's you can say atomic
Thomson's
model.
atomic model. Joseph John Thomson, a British physicist, discovered the electron in 1897. When he passed an electric current through gases at low pressure in a cathode ray tube. Thomson used glass.
You can see the 3D model of the electron. You can say discharge tube. So this is a discharge tube. I think you may have seen somewhere like this type of tube. If you have seen fuse, you can see a fuse, glass fuse or something like that in any you can say inverter, or you can say this UPS also has some fuse. So that will be a glass fuse, right? So it is same to same like glass fuse. Both the ends will be of metallic ends, right? One end will be positive, another end will be connected to a negative. So negative, as I have already told you, it is cathode, and the positive one is called anode. Then what he did, you see the 3D this one.
Tubes fitted with two metal plates called electrodes at both ends. When the electrodes are connected to the source of electricity, a glowing beam called a cathode ray traveled from the negative cathode to the positive anode. When electrically charged plates were brought near the path of the ray, the positively charged plate attracted the cathode ray, while the negatively charged plate repelled it.
So as you have seen, one side of the discharge tube is cathode, another side is anode. So negative and positive. As soon as we know that negative charges repel, unlike charges attract, and like charges repel. So same what happened, as soon as he brought that metallic surface, the cathode ray started to scatter it, or you can say starts bending it, like it was repelling it. Right, so from the repulsion we can say that the negative charge was repelling another negative charge. So we can say that this is a part which is called negatively charged thing. So he named it as electron.
A similar deflection was observed when a magnet was brought towards the cathode ray. Thomson hypothesized that the cathode ray was a stream of negatively charged particles which he called corpuscles. They were later named electrons.
Same thing happened with the when he brought a magnet also. It was repelling the thing, and then he named it as electron. And after he found the electron, he gave a point that atoms are also having a structure, or we can say that model of atom, atomic model, we can say that as well. So the model what he proposed was, have you ever seen a watermelon half cut? You can see when you cut a half watermelon, you will see a red part of the watermelon and some seeds are embedded on it. Yes. Or he also named it as plum pudding model, or you can say Christmas pudding. As Christmas is coming, we can say that Christmas pudding, right? So you have seen Christmas pudding, it's a yellowish color, and then there are some fruits or dry fruits. So he gave the same thing, that an atom is like a plum pudding, or you can say watermelon, half watermelon. So the embedded seeds were called electrons, and the reddish part of the watermelon which we eat was proton. So he gave the idea, even in pudding also, the yellowish part of the pudding was called proton, and the dry fruits or the fruits which were embedded on it was called electrons. So his proposed model was that. So you can see the structure same to same like that.
In 1904. According to his theory, an atom is a sphere with positively charged particles surrounded by negatively charged electrons. He also suggested that positive charges are equal to negative charges. The model was referred to as the plum pudding model because one could imagine a plum pudding wherein the pudding itself is positively charged and the plums dotting the dough are the negatively charged electrons. This plum pudding model of the atoms suggested by Thomson was later proven incorrect by Ernest Rutherford.
Now, what happened? This model was also a failure, we can say that. And this model was shown failed by Ernest Rutherford. We have an experiment, Ernest Rutherford's scattering experiment, which we will cover in later part of the chapter. For today, we will find out this, but we will discuss the drawbacks of Thomson's model. As soon as what happened, like when Rutherford's experiment was going on, he found that electrons are revolving around an atom, or we can say the electrons are revolving around a proton. So, and then he had started an experiment, scattering experiment, where he passed some rays and he found that some rays were going undeflected, some rays were deflected, some rays were coming back together. So he said that something in the middle of an atom is very heavy and which is constituting the atom, and he named that middle part as you can say nucleus. Like you have studied in biology, the cell's nucleus, same to same, nucleus is in the middle, which is the heavy, and the entire mass of an atom is constituted there. And then the electrons are revolving around the atom. That same model was also failed, rather than Bohr's model came, and then we are studying the present model. We call it Bohr's atomic model, which we study and which we are following and which is going in our class. So
when he showed that the positive charge is concentrated in the nucleus of the atom. Summary: J. Thomson proposed a plum pudding model of an atom. He suggested that the atom is a positively charged sphere in which electrons are randomly distributed.
So even Rutherford's model was also failed because of the, you can say, neutron. Chadwick has discovered neutron, and then as Rutherford's model was proton in the middle and electron was revolving around it, but neutron was also discovered in the later stage, and then Rutherford's model was also failed because neutron and proton were together in the nucleus and the side part was constituting that. So let's go to a quick quiz where we can see some questions, we can discover about the questions. So which of the following element has no neutrons? So we can discuss about, like I have already taught you isotopes, right? So I have already discovered isotopes. So isotopes, I was giving an example also of isotopes, like hydrogen has an isotope where there is no mass, there is no neutron, and there is neutron. So from based on that, we can say carbon, oxygen, helium, and hydrogen. We can check for hydrogen. That's correct. Choose the incorrect statement in context to cathode rays. Cathode rays start from anode and move towards cathode. Cathode rays consist of negatively charged particles. Cathode rays are deflected towards positively charged particles. Cathode rays produce mechanical effect. As we were discussing Thomson's model, we saw that cathode rays were from negatively charged particles. So we can go for that. That is wrong. Or we can say this one, start from anode and towards cathode. So it will move from anode to cathode. Who proposed the plum pudding model? Just now we got, it was Rutherford, right?
Yes.
Rutherford?
Yes.
No, it was Thomson. Plum pudding. Just now I was explaining, right? Watermelon or plum pudding model. Which of the following particle is also referred as canal rays? So canal rays, that cathode rays and canal rays are both same. So electron. No? Proton? Right. And then which of the following statement is true? The mass of the nucleus is due to proton and neutron. Electron, protium and deuterium are isobars. Rutherford explains the electronic configuration, the mass of the nucleus. So proton and electron we don't have in the nucleus, it's proton and neutron. Right?
Yes.
Now let's go to another topic of this chapter, that is
Isobars and
isobars and
isotones.
isotons.
An
Like
atom
isotons we
is
have already
made of a
done.
nucleus
Now we'll talk
around
about
which
isobars and
electrons
isotons.
revolve.
Look at the video.
The nucleus contains neutrons and protons, which are referred to as nucleons since they are a part of the atom's atomic nucleus. The mass number of any atom is the total number of protons and neutrons found in its nucleus. The atomic number of any atom is the total number of protons found in the nucleus. In this session, we look at how isobars.
So we have already discussed atomic number of an element is the number of protons, and atomic or you can say mass number is the sum of protons and neutrons. Now we will discuss about isobars, and we have already discussed isotopes, right? Same mass, same atomic number, different mass numbers. Now what are isobars? Let's talk about that.
Bars and isotones relate to these numbers. Isobars are atoms having different atomic numbers but the same mass numbers.
Now see what we have discussed in isotopes, same atomic number, different mass number. But isobars are same mass number but different atomic number. So if the atomic numbers are different, means the elements are different. So different elements having same mass number but different atomic number. So when we get this type of examples, we call them isobars.
For words, they have the same total number of nucleons. Let's consider chlorine 37 and argon 37. They each have different atomic numbers. The atomic number of chlorine is 17 and that of argon is 18. But if we look inside their nuclei, chlorine has 17 protons and 20 neutrons. The sum of 17 protons and 20 neutrons give a mass number 37. Argon has 18 protons and 19 neutrons, whose total is 37.
So the example here it is, the best example we can say chlorine and argon. Chlorine, we know the atomic number is 17, and argon the atomic number is 18. But their number of protons are 17 and 18, but neutrons are different. So like chlorine has 20 neutrons and argon has 19 neutrons. So the sum of 17 and 20 make it 37 mass number, and same here 18 and 19, 18 plus 19, that is 37 mass number. So the mass numbers are same but atomic numbers are different. So these are one of the examples of isobars.
Which is the mass number of argon. Although the atomic numbers of chlorine 37 and argon 37 are different, both have the same mass numbers of 37, making them isobars. Isotones are atoms which have different atomic numbers but contain the same number of neutrons.
Now comes the isotones. Isotones you can say different atomic number, same like that isobars only, but isobars mass number was same. But here you can say number of neutron will be same, because number of neutron is also different for every other elements. So number of neutron will be same, but mass number will be atomic number will be different. So this is called isotones.
Chlorine 37 and potassium 39 are isotones. The nucleus of chlorine 37 is composed of 17 protons and 20 neutrons, and the nucleus of potassium 39 contains 19 protons and 20 neutrons. While they differ in the number of protons, they each have 20 neutrons, making them isotones.
Same goes for the example chlorine and potassium. We have seen different atomic number but same number of neutrons. So they will be called isotones.
Summary. The
So what
mass
we
number
studied
is
here?
the total number of protons and neutrons in the nucleus of an atom. The atomic number is the total number of protons in the nucleus of an atom. Isobars are atoms with different atomic numbers but the same mass numbers. Isotones are atoms with different atomic numbers but the same number of neutrons.
So you have already got isotones, isobars and isotopes. Now
Atomic mass.
we'll talk about atomic mass.
An atom is made up of three smaller units: electrons, protons, and neutrons. The total number of one atom of an element is the atom's atomic mass. Technically, this number can be calculated by totaling the atom's protons, neutrons, and electrons. But in practicality, electrons are so small that their mass is much less than that of a proton or neutron. For that reason, the mass of an electron is not considered when calculating the atomic mass.
So atomic mass we can say that the mass of a proton, neutron and electron. But electrons are very smaller in size than proton and neutron. So in regarding with that, we cannot consider the mass of electron. We just consider the mass of proton and neutron to find the atomic mass of any element.
This means the atomic mass calculation can be limited to only the total mass of protons and neutrons. Or more simply, is the total number of protons and neutrons of an atom. As an example, look at an atom of carbon. Inside its nucleus are 6 protons and 6 neutrons. Its atomic mass will be the sum of the protons and neutrons, which totals 12. Scientists have chosen the carbon-12 isotope as a standard reference, having exactly 12 atomic mass units, abbreviated as AN.
Now, suppose you have been to a, you can say, vegetable vendor at your neighborhood, right? So you have seen they use a measuring thing, like we call it in common language daga or whatever it is, right? So you see they have only 1 kg or 2 kg of weight. But what they did, if you want 5 kgs or 10 kgs of the vegetable, they will first measure the 2 kg and then they will use the 2 kg which was already measured and then keep it on the right hand side of the, you can say, the weighing scale, and then they will measure another 2 kg, 4 kg, whatever you need. Same goes for this. So there are 118 elements to be known till now. So 118 elements, if you want to find the mass of that elements, it will be a very tough job because number of proton and number of neutron, and we don't have that kind of technology till now to exactly measure it. So what scientists have found out a way, the way these vegetable vendors are using. Like you want a different kind of, you can say, more way, he will just weigh the first one and then same thing. So what these scientists have done, they have used carbon. We call it carbon 12C isotopes. So carbon has 6 number of proton and 6 number of neutron. So based on that, its mass number is 12. And using that mass number, carbons, you can say, we find the atomic mass of different. So whenever we are finding any atomic mass, we compare it with to carbon. Like hydrogen's atomic mass is 1. So it was compared with carbon and then we found 1. And then like oxygen's it is 16. It was compared with carbon and then we found 16 this one. And carbon's already the mass is 12. So based on that, all the atomic masses were found.
Review. One atomic mass unit is equal to the mass of 1/12 of the mass of the carbon-12 isotope. Isotopes are atoms.
So as I have already told you, it was a fraction of 1/12, or we call it carbon 12 isotopes. So based on that, the mass numbers were found. So this quiz we have already done. So now, just quick revision of the class, whatever we have done. First, we have studied with the previous chapter, that was atom molecule. We know what was there in the previous chapter. Then Dalton's atomic theory, which we have learned in the previous chapter, we carried out that, and then using that we found the structure of atom. As it was already discussed that Dalton's atomic theory was proven to be wrong, as he said the atoms cannot be divided, but atoms were later on divided. Like J.J. Thomson had prepared an experiment, that discharge tube experiment, and from that he found that atom contains electron. Based on that, the theory of Dalton's atomic theory failed. It proved to be wrong because of the discovery of electron. And then as soon as the electrons discovered, Thomson gave his own model, like atoms having this, like we call it plum pudding model, or we call it watermelon model, whatever it is. So it was given that theory, you know, that plum pudding or watermelon, the reddish part was proton and electrons were embedded on it. And then later on, when Rutherford's experiment came into existence, the Thomson's model also proved to be wrong. Then Rutherford's model came that there is a nucleus in the middle of an atom and electron revolves around it. And later on, with the discovery of neutron, that was also failed, and then Bohr's atomic model came into existence, which we will discuss in our later half of the chapter. And then the things which we discussed here, the main things: atomic mass, isotopes, isobars and isotones. 4 things we have discussed. So atomic mass, it is the sum of the mass of number of protons and number of neutrons. And all the atomic mass of other elements were compared to carbon, as carbon's atomic mass was 12, as it has 6 number of proton and 6 number of neutron. And then isotopes, same atomic number but different mass number. Mass number was what? Sum of proton and neutron. And then isobars, same mass number, different atomic number. And then isotones, same number of neutron but different atomic numbers. So with this, we will wind up our class for today. I hope you all enjoyed it. Thank you.